Hello guys, and welcome to another video. So in this video we'll be treating eigenvectors of what a 3x3 matrix. Okay, so in case you new to this channel, kindly subscribe. Okay, subscribe and then hit on the bell icon so that you don't miss out on any uploaded video. In case what we are about to treat, you find it very useful. Okay, right. So without further much ado, let's just dive right into this video. Okay, so we've talked about find the eigenvectors of what a 2x2 matrix. Okay, using the simple approach. Okay, so for the 2x2 matrix, you could decide to go by the approach I use, or what further going towards Gaussian elimination. The same applies to 3x3 matrix. Okay, so for the 3x3 matrix, we have the first one is the simple approach. Okay, the one I use, the similar approach I use for the 2x2 matrix. The second one is calculator tricks. Okay, that's a bit complicated because you are just trying to predict the eigenvectors, okay, by using the calculator trick. Okay, right. And the third one is the Gaussian elimination. Okay, that's where you make portion of the rows and columns with zeros and all that. Okay, right. So in this video specifically, I'll be treating the simple approach. Okay, and then maybe in the future I might introduce you to the calculator approach. Okay, the calculator approach is a bit demanding. Okay, you need to know what you are doing. Okay, right. And then you have the Gaussian elimination. Okay, so let's proceed. So let's say you begin a 3x3 matrix. Okay, 2 1 0. Okay, and then we have maybe 1 2 1. Okay, and then we have maybe 0 1 2. Okay, right. So and then you've been given eigenvalue of let's say 2. Okay, let's say 2. So we have to find the eigenvector. Okay, right. And so we know that finding the eigenvector, we go by this formula. Okay, right. So we have that multiplying the x equal to 0. These are eigenvectors. Okay, or vector, right. So and then we have eigenvalue, and then identity matrix. Then we have the matrix itself. Okay, so let's say this is matrix A. This will be equal to A. Okay, but let's say this is B. Okay, this matrix B, this will be B, but let's say this A, so let's go with A. Right, so let's proceed. So we have our main matrix. Okay, 2 1 0 1 2 1, and then we have 0 1 2. Okay, right. And then we subtract from identity matrix. Okay, with eigenvalue of 2. Okay, so we have 2 0 0. Okay, 0 2 0, and then we have 0 0 2. Okay, right. So from here we proceed to doing a simple algebra. Okay, so we have 2 minus 2, that's 0 1 0, and then we have 1 2 minus 2 give us 0, and then we have 1 over here, then we have 0 1, and then 2 minus these 2 give us 0. Okay, right. So from here we could just introduce our x1 x2 x3. So it could be x y z. Okay, it doesn't matter. Okay, provided you end up with the eigen value, sorry, vector. Okay, right. So you have our zeros. Now from here you could notice that we are almost done. Okay, we are almost done. So we just multiply our new matrix with our eigen vectors. Okay, so we have x1. Okay, s1 multiplied by 0. So let's say x1 will be equal to 0. Okay, x2 will be equal to x2 multiplied by 1. So that's s2. s3 will be equal to 0. Okay, and then let's move on to the second one. So we have x1. Okay, plus x2 will be 0. Then we have s3. Okay, then equal to 0, and then we have the third one. So we have what? x1 will be 0, x2, okay, and then x3 will be what? 0. So from here automatically we know that what for eigenvalues, for our eigenvectors, x2, okay, x2 is automatically equal to 0. So from where we know that what x2 is 0, x2 is 0. So now let's find what x1, okay. So for x1 we have what x1 to be equal to what x3, but here is what minus x3, okay. This minus x3, and then in case you remember from our previous technique, okay, you just interchange the words or swap the coefficients, okay. We just swap the coefficients. So this is the same as what 1x3, okay. So let me rewrite that, okay. So we have x3, okay, but this is negative, so we have what -1, okay, s3, and then we have what 1s3. So let's just swap the coefficients, okay. So you know that this is x1, x2, and then what x3, okay. So let's just swap the coefficients, okay. So this is what x1, right? So this x3, okay. So let's swap the coefficients, okay, and then we have what x1 also being swapped, okay. So we have what the final answer or the final eigenvector, okay, to be -1, okay, and then what 1, okay. So this will be our what vector, okay, s2, x3, okay. That will be equal to -1, 0, and then what 1, okay. So after this you can just proceed to find what the magnitude of the eigenvectors, okay. So you have what the magnitude of the eigenvectors, okay. So we have what -1 all squared, okay, plus what 0 squared, and then what plus 1 squared. So when you compute this you end up with what √2. So now your final vectors will be equal to what x1, x2, x3, okay, right. And then you have what our main vectors being multiplied by what the root of what minus the root of 2. So we have -0, -1, 0, and then what 1, okay, right. So when you multiply this throughout you end up with a new eigenvectors to be -√2, 0, and √2, okay, right. So this brings us to the end of this video, okay. In case this video is very helpful to you, I would urge you to subscribe, hit on the bell icon, okay, so that you don't miss out on any uploaded video. Like the video, share, and then in case you have any questions just let me know them in the comment section, and then I will reply to them as soon as possible, okay. Have a lovely day. Bye bye.